Hi, my name is Jean-Philippe Fontaine. I'm the International Sales Manager at Focal, and I'm very glad to be here to introduce you our new technology called Flax. In 1985, we introduced the polyglass technology. We've been using it since then. Then the year after, in 1986, we introduced the K2 technology, which is a Kevlar composite using, of course, Kevlar and fiberglass with resin. And in 1995, we introduced the very famous W-cone sandwich. And after the third generation of the W-cone sandwiches, it's been more than 11 years that Focal didn't bring out a new technology. 2013 will be a new adventure, and I'm indeed very glad, we are very proud to be able to introduce the Flax technology. So back to the basics, if you were an acoustician, you'd be looking for three major criteria, factors, creating the ultimate composite for a driver. Those criteria, those factors, would be rigidity, stiffness, but as well as damping and lightness. Mono material are not sufficient enough, because the way you want to increase the rigidity, well, you have to increase the thickness of the composite. By increasing the thickness, you also increase the mass. If you increase the mass, you lose acceleration, right? So you are losing efficiency. Efficiency is out of the utmost importance. In our quest of looking for this ultimate material, well, it happened that this material was in France. We cultivate it in France, and we have a strong know-how about this material. This material is linen. And out of this linen, we create the flax. The flax has tremendous characteristics. The characteristics I just spoke about. Rigidity, stiffness, damping, and lightness. Flax is extremely rigid. Young modulus is about 60 gigapascal. This is very, very close to Kevlar, because the Kevlar is only 62 gigapascal. So we have found a very good materials in terms of rigidity. But not only, because it happened that flax is about 80% made of cellulose. What is cellulose? It's paper. And as you know, paper has a very, very good damping. Okay? It's also very, very light, because the fiber, one fiber of flax is only 20 microns. Back to the density, flax have a very, very low density, because it's a hollow fiber. The inner part of the fiber is absolutely empty. So having found this perfect material to build our drivers, we also apply our own know-how that we have had since polyglass, K2 and W, meaning that we have different layers, and we can adapt the number of layers, the thickness of the layers, the density of the layers, according to the needs of the driver that will be fitted inside a speaker. So we can adjust the density of the flax, in the middle, but also the thickness of the fiberglass tissue that is being used on the outside, on the front and at the back. And modifying those different layers, we can modify the parameters of density. We can modify the parameters of rigidity, stiffness, lightness, acceleration, and damping. So we create a membrane specific for a mid-range or a woofer that will be specifically built for our different speakers. So finally, creating this Flax technology, we have come very close to an ideal membrane to fit in our drivers. Those drivers will be used in our new product line called ARIA 900. So I hope I was clear. Thank you very much for listening, and I'll see you next time.